I'm trying to post the recording for review. All right. So definition logs. This is the mantra you need to remember. The opposite of a log becomes the base of the exponent. I should say it like this. The base of an exponent becomes the base of a log. The base of a log becomes the base of an exponent. Here is the general thing. I'll write that down too. Base of a log becomes base of an exponent. Okay. So what does the concept mean? That means if I have something like this, let's do it like 3 to the second power equals 9. I can rewrite this. If I move the base of the exponent, it will become the base of a log. So it will become 2, a normal size 2 gets moved down, equals log with a little base 2, 9. The base of 3 moved, oh, this is 3, yeah, you're right. All right, so the base of the exponent becomes the base of a log. Yeah, just take another picture. Right? What? Take another picture. I'm starting my review. Okay. All right. The base of an exponent becomes the base of a log. The base of a log becomes the base of an exponent. What's up? Normal size 9, yeah. Now, it works the other way too. Log base 4 of 2 equals a half. Here, the base of the log, if I want to move it to exponent form, becomes the base of an exponent. The base of a log becomes the base of an exponent. So normal size 2 equals the base of the log, which was 4, becomes a normal base of the exponent, 4 to the 1/2 power.
Oh, I understand.
So this is rewriting. If I ask you to simplify, for example, if I ask you to simplify log base 10, 100, 1000.
1000 equals 10.
So what you would do is you set it equal to X. Guys, you would set it equal to X, then bring the 10, base 10 over to the other side. So it'll be 1000 equals 10 to the X power. Then you ask yourself, 10 to what power would give you 1000? This is a little mental math. If not, you could just type in your calculator. No, not necessarily. But this is going to be 10 to the third. Because 10 to the third would give you 1000. No. Yes. That's fine. I understand. So log base 5 X equals 3. Hey, I want to go over the review. Please stop talking. Guys in the back. Yes. Yeah, you got to put an X. That might be, it'll just say simplify or something like that. All right, this one, I got to move to, please don't forget this. It's literally like 75, if not 80% of your tests. The base of a log, when you move it to the other side, becomes the base of an exponent. X equals 5 to the third power.
So 25 times 5?
Yep, which is 125.
Okay, but would you want us to simplify it all the way, or like 5 to 35?
No, I'll do 125 in this one. Okay. That's the concept, all right? It's just move the base of the log becomes the base of the exponent. Vice versa also. Base of an exponent becomes base of a log. If you understand that, you're going to understand 3 other sections for free. Any questions?
Five.
Okay.
Can I ask you the homework question?
Now I'm gonna go over all the sections so I can put this in a recording and hopefully post it if it converts
Do
correctly.
you think it's gonna save this time?
I hope so. The problem is it won't convert. So it saves, but then you can't watch it though, because it's in a different video format. So 10.5 is law of logarithms. Remember, this is related to the laws of exponents. Here's the concepts. There's 3 laws we went over. Log, let's say A plus log B equals,
Log C.
no, A times B. I wrote these for some reason. Equals log AB, aka A times B.
That's a
So,
log.
if addition, then multiply. Okay. We're gonna do the opposite now. Log A minus log B
I have this on.
equals log A over B.
I think that's 17. Ours is 6.
If subtraction, then divide. Hey, so. If subtraction, then divide. Last one. A log B. So this is multiplication.
So it's addition. Plus log A plus log B.
No, it is going to be log A. I'm sorry, log, not log A, log B to the A power. Remember, numbers in front move to the top.
Oh, because it's meant to be a number.
Yes. So please understand, if multiplication, then exponent. Okay. If they're multiplying to each other, then it's an exponent. Okay. Which means in this section, we're going to do 2 types of problems. We're going to do expand problems. When I give you something like this, log 3x y to the second. In this one, we would make the log into multiple logs. Since this is multiplication on the inside, it becomes addition on the outside. So log 3 plus log x plus log y squared, but the y is not by itself yet. Perfect. We're going to take the 2, move it to the front. So it's the same thing here, log 3 plus log x plus 3 log y. 2 log y. What would you put in between them? A subtraction. You would just put a minus.
No, I mean, like you said, multiplication that exponent. So what about division?
The division is still an exponent, you just be a fraction. I'll just put that as an example. That's not a bad question though. Let's say if I had log x divided by 2, you're like, wait, what am I supposed to do here? You would rewrite it as 1/2 log x. Once it looks like that, is it obvious what I need to do?
It would be log x to the 1/2 power.
Good, log x to the 1/2 power.
Because that's the rule, a log b equals log b. What? I know this one. I
So,
picked true.
guys, next one is condense. So there's a reverse.
Oh my God.
So let's say log x minus log y plus log 7. Because log y is being subtracted, you know that's a division. So you could rewrite this as log X over Y. Now, because this is addition, you're multiplying. You're multiplying 7 with X over Y. So you could consider this 7 over 1 times X over Y. That's going to become log 7X over Y. Yes.
That was the span problem.
Yes.
How do you act with the final answer is 2 log Y?
That's going to be part of the answer. So it's log 3 plus log X plus 2 log Y. I did not finish this part, so I didn't want to rewrite it twice. That's all.
Okay.
Yeah, no problem. Okay. Are we ready to do the next one? You good? Get it down, get it down.
Okay.
Ready? All right. Okay, next section. 10.6. Okay. Now, applications of logs. The review and how we use it is going to be using a calculator, okay? These are impossible to do otherwise without a calculator. And there's some that's not on this review sheet. I will give you some that has to do with not a calculator. So let's do the calculator version first. All right. So for this one, if I ask you, please give me log. Let's say, I'm just picking number 2 here. 32, 200, something like this.
You just put in your calculator, right?
All you do is put in your calculator.
It's 4.52.
Good. Let me just share it so I could show the screen too. Okay, so for this one, you literally just click the log button, 33200. So enter 4.52. I'm going to ask for 2 decimal points. So 4.52. Again, just plug it into your calculator. Pretty straightforward. Now, if we have a situation like this, where it's log X equals, let's say 0.5009, so 0.5009. That's true. You can't get an X on your calculator.
Do put it to log 0.0.5009.
The base of the log.
Base of the log becomes base of the exponent. If you don't see a number on the bottom of the log, it's divisible 10. So I'm going to make the base of the log, which was 10, to become the base of the exponent.
So it'd be
So
X
X
to the power of
equals
that.
10 to the power of that.
Good. So
That
0.5009. That is going to be the exponent. In your calculator, you're going to click 10, type in 10, then the caret, which is above the division symbol. Then put the decimal 0.5009.
3.197. Why not?
3.17.
Oh, yeah.
What would it be 9?
I was just thinking because 8, the next one's 9. But I thought that was the 6th one.
So 3.17. And then we might have it in the opposite way. So this one definitely, this is going to be, let's say log. Oh, wait, no, I'm sorry. Erase the log. Let's say it'll be an exponent. So let's do 3.1 to the X power equals 300. In this situation, we're going to take the base of the exponent over here, move it to the other side.
So log 3.1.
Good. So we're going to have log 3.1 as a base. So that's a tiny 3.1, 300. But we have to remember, we don't have a button for log 3.1. So we have to rewrite it using the change of base formula, which means it's going to look like log 300 divided by log 3.1.
That's always to put in the calculator, like.
That's how you have to put it in the calculator. And I'll show you in the calculator. Log 300, close the parenthesis, or you're going to make a mistake, divided by log 3.1. So your answer is 5.04. Okay, so application of log, not too bad. Just really calculator stuff. If you know how to type a calculator, you'll get this part section right. Guys, did anyone else need this up, or can I go to the next one? Okay. 10.7. Problem solving, aka word problems, exponential, growth, and decay. Okay. When you have interest, is an interest problem of some sort? This is your equation. A equals P1 plus R over N, close parenthesis, to the power of NT. Okay. Guys, remember, A is your final amount. P is your principal, aka your initial amount. Starting amount. R is your rate. What is the percentage? Remember to change the decimal. N is the number of times per year. Again, for example, if I said monthly, that would be 12 because there's 12 months a year. And then T is the amount of years. Okay. So, for example, let's do a $1,000 is invested at 8%, compounded quarterly for, let's say, 5 years. Quarterly. Okay. So in this one is let me identify all the variables first, but I think you're getting the setup correct. A, the end amount I don't know yet, but I know the principal should be $1,000. I know the rate, which is 8%, but I don't want it to be 8%. So I got to change it to decimal, which is going to be 0.08. The N is the number of times. Since it said quarterly, that would indicate that's 4 times a year. And then T is the time, which I said was 5 years, so that'll be 5.
But I have a question.
Yes.
In one of the homework problems, it said $1,000 invested at 12% interest compound annually.
So that's once a year, right? Every year.
Oh,
So 1,000 equals 1 plus R, which is 0.08 over N, which is 4, close parenthesis, N, which is 4 times H, or I'm sorry, T, which is 5. So a little bit of math, 1,000 equals, this is 0.08 divided by 4. What's 8 divided by 4? 2, so it's going to be 0.02. So it's 1.02 to the 20th power, because 4 times 5 is 20. This one I would expect you to do in your calculator. So 1,000 times 1.02 to the power of 20. Remember, the caret is power. So the money I will have in my account, since this is money, will need 2 decimal points. 1,485.95.
and how do you know the growth or decay?
We'll talk about that next. This is just an investment. 95. There might be some where you have to move the base of an exponent to the base of a log somewhere, but this is a basic version of the question, okay? Okay. So 10.7 continued. So 10.7, we have the growth formula, which is N equals N sub O, or N sub 0, times 2 T over D. We also have the decay formula, or we call the half-life formula. N equals NO times a half T over H. You really want to play that now? Come on, man. So this one is doubling, and this one's half-life. As a reminder, N is the final amount.
Is half like decay?
It is technically decaying by half, you would say.
Yeah, so.
Is that no number?
N sub O, or N sub 0, I should say, not N sub O.
Is that like the starting amount?
Yes, starting amount,
It's initial.
initial, yeah.
Initial velocity.
T is going to be how many, the time period, so the total time, I should say. And then D slash H, so D slash H, both of these apply. How often? Often, often. It doubles slash halves. So D is for the double, H is for the halves. Okay, so very quick question. The half-life for an element is 10 days. If you started with 57 grams of the element, how much would be left after 100 days? I'll make this a little bit smaller size space. Okay. If a half-life for element is 10 days and you started with 57 grams, how much will be left after 100 days? So here, let's identify our things. N, we don't know what N is yet, so we'll put a question mark for that. N sub O, or N sub 0. We know what we started off with, which is 57 grams. T equals the total time. So the total times 100. While in this case, since we're cutting it half, it'll be H. We're halving it every 10 days.
So it's 100, so it's 1/2 to the power of 10.
So it's going to be 57 times 1/2 to the power of 100 over 10, which will be 10 after you simplify. So N equals 57 times 1/2 to the 10th power. From here, you could put it in your calculator. You could technically do half power 10th, but whatever.
Because 0.00097.
No, what I would do instead is do a half and then to the 10th power. So 1/2 to the 10th power to be
5, 20.
no. So it'll be 57
Oh, that was.
times. So I'm going to put 0.5. You could put 1 divided by 2, but 0.5 works also. To the power of 10. So in this case, oh, that's what you might have been saying. Let's go 2 significant digits. So 0.056 grams.
And we need units.
Since this is a word problem, we would need a unit, yeah. Doubling works the same, so I'm not going to spend time for that. I want to make sure I cover everything at least. I hope so too. All right, last one. Oh no, I'll cover the last one next time we meet. Actually, I'll just continue. You guys have a wonderful day. 10.8 natural log. So the natural log is nothing too special. It's just that the E value has a very special value, which is like 2.71828. You don't need to know this, but it is a special value that we care about, and it shows up in problems that we'll use in the future. Right now, all you need to know is that log base E is the same as ln, not in ln. But all the rules that we applied in the previous sections will apply to this. So for example, if I want to solve ln 10 equals 2.3, if I want to solve that, I'm going to move the base of the log to become the base of an exponent. The base of a ln happens to be e. So it's going to be 10 equals e to the 2.3 power. I already knew the answer was 10, so I don't have to actually type this in your calculator. We'll also do the reverse, where we have e to the 4th. Make that e nicer. E to the 4th equals 54.6. If I want to turn it into log form, I'll take the e, move it to the other side. 4 equals, e is going to become ln 54.6. Okay. As a rule, if you have the same base, so let's say 3 and a normal 3 to the, let's say 7 power, you could cancel out the base of the log and the base of the exponent. and it becomes just 7. Also works the other way, where the exponent 3 to the exponent log base 3, 7. The base of a log and the base of an exponent cancels out. So this will also equal 7. If that is true, that's also true for ln. If you have ln e to the 7th power, ln is base log e, so that cancels out, which means it's just 7. With base ln, you could do all the work from the previous sections. For example, if I had ln 3 plus ln 7, that tells me I need to multiply. So ln 3 times 7, which equals ln 21. Hope this helps. Good luck with the test.